which some of you may also know as Fig. Brilliant. And what I want to talk about is a few ways you can use Compose, which is more than just development environments. It was originally a tool built for running development environments using Docker. And it's, with a single file, you can define and run multiple service applications. I'll talk a little bit about that. Used to be called Fig, which some of you may have heard of. We recently renamed it to Compose. Figs are kind of gory, aren't they? I'll switch to the next slide. Who here actually has heard of Compose or Fig? Cool. And who has used it? OK, great. That's quite a lot of people. That's really good. Basically, the core problem that Compose is trying to solve is that running multi-container apps is a bit of a hassle. You have to build images from Docker files, you have to pull images from the hub, you have to then configure and create the containers using lots of run options, and you have to start and stop these containers and try and stream their logs to figure out, what's doing what. And lots of commands to run, lots of things to remember. You can sort of hack it together with shell scripts, but then it doesn't really work properly. What Compose does is you define all of this stuff in a single declarative file. Then you can run a single command, and it sort of pulls things, it builds things, it runs things, and then connects them all together, and aggregates all of their logs. So you don't sort of have to think about that. And the particular thing it does really well is if you are working on a piece of software which consists of multiple services, so a web server, a database, a cache, queue servers, stuff like that, you can put a Docker Compose file in your repository, and then anybody who wants to work on that app can just run Docker Compose up, and they have the whole thing running. Essentially, your getting started guide for new developers on applications can just be one command, Docker Compose up, and they don't have to worry about anything. And I'm just going to, probably the best way to explain what it is just to do a quick demo of how it works. This is a really simple Python application. You don't really have to read or understand this, but essentially it's a thing which stores a counter in Redis of how many times you've viewed this page. So each time you visit this page, it increments a counter. And there's also some requirements, Python requirements, which installs Python libraries. There's also a Docker file, and this is the thing that packages up this Python application into a Docker image and installs our Python requirements. And then there's the bit which is, if you've used just Docker up to now, this probably looks somewhat familiar. But we're also adding a new file with Compose, which defines what all of the services are and how they connect together. So we've got a web server, which builds the Docker file in the current directory. We've also got Redis, and then it links the Redis, links the web container to the Redis so they can talk to each other. And I can show this working, which, with any luck, can you see that? Brilliant. So in this directory, I've got those files that I talked about before. And I can run Docker Compose up, and boom, my application's running. And I had the images pulled there because I'm on conference Wi-Fi, but if I didn't have the images pulled, then it would do all of that for you. And then I can go to this application in my web browser, and it is counting how many times I viewed that page. That's how Compose does development environments. That's pretty simple. And that's sort of what Fig originally was, and kind of what everyone sort of started using Fig for was for running development environments, and it was really good at that because the huge value for developers was being able to share your development environments like that. And this is sort of something that started with Vagrant, where you could type Vagrant up and run your entire application. But Compose just sort of made that much more simpler for if you were running your development environment just with Docker containers. You didn't have to configure Vagrant to then set up Docker. It was just all sort of all a single experience. But Compose can also do a bunch of other stuff. One thing it's particularly good for, and one thing we actually see people using it a lot for, even if they don't use development environments, is using Compose for running your CI tests in things like Jenkins and, well, not Travis, but Jenkins and that sort of thing. And essentially the idea is that there's this Compose command called run, which will run a specific command in the context of a Compose application. And it's pretty much like running your development environment, but on your CI system. So the big advantage of Compose is that it packages up all of your application's dependencies, including all of the other services like databases and message queues and that sort of thing. And that's really useful for running CI tests as well, integration tests and stuff like that. So all you need to do is essentially just use Docker Compose to run a script which is your tests, and it works exactly like it does in your development environment. And in fact, this is really good in your development environment as well, because you run your tests like this when you're developing. And I can demo that actually using the existing environment we had here. This is it aggregating the logs from the thing we were running before. I can quit that. Stopping. Can kill it. I can just do, so in this directory I've got test.py, which just does a simple test against this application. And I can do Docker Compose run web, so it runs in the context of the web application where all the code is, and then runs that test file. So it will start Redis, which is needed to run the tests, and then it runs the tests. And it's completely self-contained. So that's really handy, like particularly if you imagine your Jenkins scripts, it's essentially just that. And then you don't need to install databases and that sort of thing on your CI system. It just kind of all works. So yeah, what I just said, basically run your development environment in your CI scripts, and has all your dependencies, and it's self-contained, which is really good. Another thing that Compose can do, and this is sort of where it starts to not be very good, but if you're interested in experimenting with this sort of stuff, it can start to do things like this, is running Compose in production. And one of the things it can do is if you've got a really simple application that just needs to live on a single server, so say it's your blog or something like that you're running on a DigitalOcean server, it actually does this really well. So you can put your code onto your server, which you can just do with git clone or git pull from wherever your repository is, then do Docker Compose up with the -d flag. And the -d flag is a bit like the -d flag on Docker run, which will essentially run your containers in the background. And then your application is running on your server. And this is just a single server, so it obviously only works for very small things that you don't really mind if they break. I can demonstrate this quickly using the application we've got here. So if I do Docker Compose up -d against that application, it starts the application. And then we've got a bunch of commands which sort of, in a way, resemble something like Heroku, where we can do PS and see our application running. We can do Compose logs and tail the log output from these containers. But this is all running in the background. So I've quit this, and if I go to my browser, then my application's still running, but it's just all running in the background. And you can do, this is on my laptop obviously, but this is what it would be like if it was running on a server. Generally, obviously, I wouldn't really recommend this because it's running on a single server. If the server goes away, you lose your data. It obviously doesn't scale. And it's a bit of a hack, but this is kind of a useful technique if that's the sort of thing you want to do. There's also a variation on this, which is you can put that essentially in an init script. So you can use upstart to manage this, because the disadvantage of this is if your server restarts, then your containers don't restart. You have to run Docker Compose up -d manually, and that kind of sucks. So alternatively, you can put it in an upstart script, which is essentially the same thing. You just change into the directory where your application is and do docker compose up in the script. This can be with whatever init system you like. It's essentially the same thing. That pattern works quite well as well. But again, this is the same problem of where it's on a single server. Obviously doesn't scale, and you're going to lose your data if your server goes away, which is not very good. So this is sort of where another component of what we're building at Docker comes in, which is Swarm. And if you were around this morning, you would have heard a bit about how Swarm works and what it is. Just really briefly, it is native Docker clustering. So it turns multiple Docker hosts into a thing that looks like a single Docker host. So it serves up the same REST API. You can use the same tools against it and all that sort of thing. And it has pluggable backends for doing different scheduling and node discovery. That's kind of what it looks like. It's a Docker client which talks to Swarm, which then talks across two different hosts with Docker engines running on it. And to the point of view of the Docker client, it looks like a single big computer. And this is an interesting point about Compose, is that Compose is also just a Docker client. What Docker's doing in that demo I just gave is it's talking to the Docker engine over the REST API. It's doing the exact same thing that the Docker command line client does when you do Docker run and Docker PS and that sort of thing, except it's just doing lots more API calls. And it essentially has no other dependencies apart from being able to talk to a Docker engine, well, to a remote API, the REST API that the Docker engine serves. So what we can do is we can just replace the Docker client with Compose, and in theory, everything kind of works. That's the theory, and we're getting there. It's not quite there yet, because Swarm doesn't implement the whole Docker API yet, but it implements enough to make it useful. A few things that Compose will do to make it work is it co-schedules containers which depend on each other to be on the same host. So if you link to another container, it'll be scheduled onto a single Swarm host. If you want to schedule stuff across multiple hosts, then you kind of have to figure out the networking yourself. And we're kind of improving this over time. And as Swarm implements more of the Docker API, this will become much better. But there are a few difficult bits which Swarm can't magically solve for us, which is networking, particularly networking in volumes, but also builds. Networking is, if you link a container on one host to a container on another host, how do they communicate with each other? And volumes is if a container stores a bit of data on a host, and then that container then gets scheduled onto a different Swarm host, where does that data go? You've lost your data. And these are things we're working on at Docker with plugins, with networking and volumes plugins, which Luke Marsden talked a little bit, or sort of mentioned briefly this morning. And he also mentioned a demo of Swarm and PowerStrip and Weave and Flocker, which was kind of an attempt to solve this problem. So PowerStrip is a tool for prototyping Docker extensions, which just intercepts API requests. So when you create a container and it says, I need a network, then the API request can get intercepted and it can go off to Weave and create a network and all that sort of thing. And this is also integrated with the Swarm, so it works across multiple hosts. And in this demo, which is on ClusterHQ's blog, it just works with the Docker client. But surprise, Compose is also just a Docker client. So this is kind of how this could work. So Swarm creates a single virtual Docker host out of multiple hosts. So it just exposes a single Docker API endpoint. Weave then networks these hosts together. Flocker stores the data, so it's not tied to a single host. PowerStrip sort of ties this all together with some magic. And then, on top of all that, compose defines and runs your app. So this is the diagram of what it looked like before, with just the Docker client, and with this big stack of lots and lots and lots of pieces, which sort of make the swarm kind of look like a single thing. And of course, we can just swap out compose with this thing on top. So let's give this a try. I was originally not going to give this demo because I thought this is just going to break. Like, this is so complicated that there's no way this will work on stage. And obviously, like, disclaimer here, this is obviously really experimental as well. I would definitely recommend not running this in production. But let's see what happens. That's the thing we were running before. Power strip and swarm. Right. So I've got it's essentially, there's this demo which is up on GitHub, which I'll link to afterwards. There's lots of pieces to sort of get that big diagram that I showed before, get that all bootstrapped and running. The crucial bit of this demo is the docker compose.yaml. So we've got two services, which are essentially a web server and what's called an API, but it's essentially a database. It's storing some data in a volume. These are both images that are hosted on the Docker Hub. This web server exposes a web application, and it also configures a bunch of stuff with environment variables. So it's configuring. So Weave is configured in an environment variable, and this tells Weave that I want this container to have this IP address and be on this network. And then it's also just passing a bit of configuration to the web server as well to say where the API server is, where the database is stored. So in the API server, we've then got a similar thing where we're telling Weave what IP address we want this to have. And we're also adding a swarm constraint to this container as well. So we're saying, please schedule this API server on a node which has a disk in the swarm. So in the swarm, different nodes can be tagged with different, and different nodes can have different tags in the swarm. One of them has the disk tag. So we're telling Swarm to always schedule this onto that node. And then we're also saying store the data for this inside a Flocker, volume. Does that kind of make sense? There's lots of pieces to sort of piece together here. But essentially the idea is that this is deploying on a swarm with multiple nodes. Weave is making sure those nodes can talk to each other, or containers running on those two nodes can talk to each other. And Flocker is making sure that the data can be transferred between those different nodes as well, which we'll come to. And this is my swarm I've got here. So if I run docker info, see we've got a swarm with 2 nodes. And if I run docker ps, we can see all of the containers that are running on the swarm. This is basically all of the stuff that runs PowerStrip and Weave, which I prepared earlier. But the crucial bit is we can see that if you see this name here, these names here, some of these are running on node 1, and some of these are running on node 2. So some of these containers are running on one of the swarm nodes, some of them are running on the other swarm node. So swarm has kind of done its job and scheduled containers on both things. Well, actually, no, this is the PowerStrip thing that's set up. But anyway, the point is that there's containers running on all over the swarm. And Swarm is aggregating it together into a single docker ps output. So now we've got this docker compose.yaml in this directory. We can run docker compose up-d, and it's configured with the swarm, and boop, boop, and woo, our application's running on the swarm. That was quite cool, wasn't it? I'm going to actually prove that it's running. So we've got docker compose ps, which is running on here. It doesn't actually output what node it is. That's just a thing we haven't added to compose yet, but I can show you that it's running on the swarm. If I grep for that, so it's actually scheduled it onto the same node, but that doesn't matter. Swarm is just scheduling it randomly. So the web server has gone onto node 1, and the API server has gone onto node 1 as well. And if I grab this IP address and port from the compose outputs, I can put this into a web browser, and it's doing kind of a similar thing to what the demo did before. It's counting how many times I'm viewing the page, except this is all using Swarm and Weave and Flocker and a whole bunch of other things, which is quite cool. Now, this is like the surprise bit where like Flocker and Weave does its magic, which is in the Cluster HQ blog post by writing loads of Docker commands. You have to Docker stop this, Docker run this, Docker remove this, and run with loads of options to sort of specify what you want to do. Because we're using Compose, we can just update things in the Compose file, and it just kind of works. So these two nodes we had in our swarm, one of them was tagged with having a spinning disk. The other one was tagged with having an SSD. So let's say everything's running a bit slow, and we want to move our database onto the node which has an SSD. What I can do in my Compose file is update disk to be SSD. And then I need to stop and then restart the database. So if I stop it, oops, whoops, just the database. Let's start the actually, no, it doesn't matter. Remove the database. Then start it all up again. What it's going to do is it's just restarting the web server in place. And this is taking a bit of time because Flocker has realized, this container now, Swarm has realized, this container now needs to be on a node with SSDs, so it's scheduling it on another container, and it's then tried to mount the same Flocker volume onto that host, which is on a different host. So Flocker has realized, I need to move that volume from the host it was on before to the new host where this container now is, and boom, this is now started. So if I refresh this, the data is still in place, but if I do PS, the API, it's now running on node 2. And before it was running on node 1. And it's still got the data it had. Yeah, I'm glad that works. So that is all of the things, all in one demo. Probably an unnecessary amount of things. This is the original blog post by Cluster HQ, which is demoing Swarm plus Weave plus Flocker plus PowerStrip with a Docker client on top of it. And then this GitHub repository here is the same thing, but with Compose on top of that as well. Yeah, I hope that made some sense. I wasn't too mad. Any questions? Yes.